Okay, so in the last few videos, we've been talking a lot about where is the middle of the data. Okay, and that is a big thing because people like to know what to expect, and the middle of the data is a big part of that, at least usually. But another thing, another element of understanding a set of data is how spread out is it? Okay, for example, if I have a set of data like one, one, two, three, four, four, okay, that's not really all that spread out compared to 10, 13, 28, 49, uh, 307. Okay, this data is much more spread out than this data. So, and the more spread out it is, the less consistent that it is. Here, the data is very consistent, but it's not, well, yeah, but it's not spread out. Okay, and so those are, that's something to think about. Now, there's different ways to determine how spread out the data is, or to determine the spread outedness. That's a word I made up. So, where's the center of the data and how spread out is it? So, Italian Tours offers a daily sightseeing trip around Florence. The list below gives the number of people who made the trip for a selection of 9 summer days. Okay, find the range of the data set. Now, the range, that is an easy way, kind of an off the shelf way of getting an idea of how spread out the data is. But as I'm sure you're already aware, if something is easy, it does not tend to be valuable. So to get the range, you do the high value minus the low value. Very natural. Okay. So in this case, the biggest value is 64. And that's the high. And the low, let's see, 27. Yeah, 27. Okay. And we get 37 for the range. Okay. And that's how it works. Now, like I said, if something is easy, it doesn't tend to be, especially valuable. Sometimes it is, but not normally. So, if I've got a range of 37, well, okay, this set of data here has a range of 37, but those are commas in between a whole bunch of ones. That set there has a range of 37. Okay. Are they equally spread out? No, they're not. This one is all the same thing, except for one number. And this one is completely disparate. I mean, pretty much everything is different. It's much more spread out. Yeah. So range is a very quick, easy way of getting a rough idea, and I do mean rough, of how spread out the data is. But that's all it is. It's just high minus low. It's something you can often do just in your head, which is nice. All right, so now we're going to find the mode and range from a line plot. Again, some people will call it, I think I mentioned this in a previous video, a dot plot or dot graph, line, whatever, it doesn't matter. All right, the mode, oh, by the way, remember how I said, oh yeah, that's the special symbol for mean, and that's the special symbol for median. Well, there is no special symbol for mode. You just write mode. So the mode, again, that's the number that occurs the most often. Well, 1 occurs twice, 6 occurs 4 times, 7 occurs only twice, and 9 occurs once. So 6 occurs the most, so the mode is 6. No big deal. How about the range? The range is your biggest value. We've got a 9 over there, minus your smallest value. We got a couple of 1s, so 1 is the smallest value. Okay, so yeah. Anyway, that's all you do. Okay, so on this one, we read, we've got 4 teams, and we have the mean for each team and the range for each team. So it says, based on the information above, so just this information here, which team has the oldest numbers on average? Keyword is average and oldest. Okay. Well, that makes reference to mean. It can also make reference to median or mode, but we're not talking about those this problem. So which one has the biggest mean, the oldest mean? That would be right there, team C. Part B says, based on information above, which team's ages have the least variability? Variability, spread outedness. Now we're talking about range. Okay. So which one has the least variability, the smallest range? Well, that would be right there, the 11. So team B. That's what we do. Okay, on this one, um, what I'm going to do is I'm going to use what Alex has written, because I think there are some subtle points there that Alex uh, phrases quite well. So we're going to include that. All right, so Gadabout Tour Company gave bus tours last summer. The tour director noted the number of people served by each of the 46 tours. The smallest number of people served was 46, and the largest was 54. Okay, so the table over here gives the mean, median, range, and interquartile range of the data set. Okay, now we're not going to get, I know you haven't seen interquartile range yet, at least not in this class. If you have seen it elsewhere, bravo, that's surprising, because it's not like something everyone just goes around talking about. But so I'm not going to get into the formula for it, but the interquartile range, it includes the word range, so it's a measure of spread outedness, variability of the data, and it examines the middle half of the data, the middle half, not the top half, not the bottom half, but the middle half. Okay, so part A, select the best description of center of the data set. Okay, so we don't care about range or interquartile range for that. We're thinking mean and median. Okay, let's see. Looking at the range, we see that a typical tour served about 8 people. Okay, that has to do with range, so that can't be it. The third one, looking at the interquartile range, we see that a typical, okay, that can't be it. So it must be this one. Okay, looking at the mean and median, we see that a typical tour served about 51 or 52 people. Yeah, that's it. What does the author have to say about that? The author says the mean 51, median 52 are both measures of center. The range and IQR are not, they're measures of spread. Looking at the mean and median, we see that a typical tour served about 51 or 52. Okay, that wasn't the most exciting phrasing. Okay, now the author does talk a little bit about the IQR. Okay, so it says, okay, like we saw before, the range gives the difference between the largest and smallest values, but the interquartile range tells how wide the middle half of the data set is. Okay, because it's a measure of how spread out the middle half is. It is a difference between the center of the right half and the center of the left half. Okay, so there's some good information there without giving you the formula for figuring that out. Okay, or for understanding IQR. All right, part B. Select the best description of spread for the data set. Oh, now we're talking about spread, so we're not talking about mean or median. The middle half of the data set is 6 units wide. This is the IQR. Well, that might be it. Interquartile range does have to do with the spread. The middle half of the data set is 52 units wide because that's the median. Median has nothing to do with how spread out the data is. It has to do with measure of center, so that would not be it. The middle half of the data set is 46 units wide because this is the number of tours given. Well, the number of tours given is just how many data points you're working with, not how spread out they are. So that could not be it either. So it must be the first choice. Let's see what the author has to say. So describing the spread of the data set, the IQR 6 and the range 8 are both measures of spread. So, and they only gave you a choice of one of those two. So you pick the one that actually talks about it. Part C, select the graph with the shape that best fits the summary values. Okay, the summary values being these 4 guys right here. Okay. Well, one thing I noticed was it says, okay, the mean is 51, the median is 52, so the center of the data is around 51, 52, which is going to be, right here is in between 51 and 52. Now, every for this graph, 46, 47, 48, they all have the same height. In other words, they all occurred the same number of times. So with that in mind, does this look like the center of the data? No, this looks more like it. Okay, but 50 was not given. So it's a good bet this one is not the answer. Okay, so let's take a look what the author has to say. Okay, the mean and median tell us that the center of the data should be around 51 or 52. Okay, so I said that. We know that the number of people served ranged from 46 to 54. All right, now both graphs do start at 46 and go up to 54, 46. Okay, so, if one of them did not, then we could just throw that one out right away and say, hey, you don't have the right range. Okay, we also see that the mean, 51, does not equal the median, 52. So the data set is not symmetric. Oh, so if the mean and the median were equal, the data set would be symmetric. Well, graph 1 is definitely symmetric. You slice it down the middle and both sides look like each other. Graph 2 clearly is not, so we're going to go with graph 2. Now, there's more we could say about graph 2, but that's maybe beyond the scope of this topic right here. All right, now last one for the chapter, comparing sample means. 3 students want to estimate, oh, wait. Okay, sample again. Population, that's everything you're interested in. Okay, so if you're saying, hey, I wonder what the average TVCC student, or how many donuts the average TVCC student eats in a week. Okay, so then your population is all TVCC students. Okay, and then a sample would might be, well, everybody from this one class, I asked them, or something else, a portion of that population. Or what if you say, well, I'm interested in how many donuts the TVCC women eat in a week. Now your population is just TVCC women, and that would include anybody at TVCC. I didn't say students that time. So so it'd be female teachers, female students, female staff, whatever. Okay, and then a sample of that would just be part of it. Okay, so 3 students want to estimate the mean word length of the same book. Okay, so 3 students, they all have a copy of the book. So they've all got the same book, and each one of them, and none of them want to actually count all the words one at a time. They want to use statistics to save time. So they're going to do apparently different ways of calculating, use different samples. So to do this, each student randomly chose 4 words from the book and recorded their lengths. Okay, the samples are shown in the table below. All right, so the first student, let me turn this thing on. Okay, so the first student got a 2-letter word, so like in or on or something, and then a 6-letter word and a 5-letter word and a 6-letter word. That's not much of a sample. I mean, especially when the book, probably has 90 to 120,000 words. And you could very, very easily do 100 words, or do 100 words in your sample instead of just 4, but whatever. They didn't want us to have to do, crazy calculations. So that was nice. So, so here are our samples. We got all that, and that's cool. Oh, and we got to get the sample mean from each one. Okay. So if we do, let me turn that on. Okay, so if we do the first one, let's see, that's going to be 2 plus 6 plus 5 plus 6 is going to be 19 divided by 4. It's going to be 4.75. The next one, 8 plus 4 plus 4 plus 3 is 19. Same thing. The next one is 2 plus 6 plus 4 plus 5 is 17, and that'll be 4.25. Nice thing about dividing by 4 is you don't have to worry about rounding your number off. Okay, you can get the exact answer. Okay, did I do that correctly? 12. Yeah, okay, cool. All right, so part B, use the table to calculate the range of the sample mean. Oh, so we're not being asked to find the range of each sample. The range of the first to be 4, and then 5, and then 4. Okay. We're being asked to find the range of the sample means. So we just calculated these statistics over here. Now we want to calculate a statistic, sample range, okay, based on these statistics. This gets into what's called the central limit theorem, which we need to worry about, but it's a major theorem of statistics that allows you to go from basic statistics like we've been talking about, which are very, very useful, and taking it to a higher level, like with confidence intervals, hypothesis testing, and stuff like that. Okay, so the range of the means. Well, the biggest mean is 4.75. And if we subtract from that the smallest mean, 4.25, we get 0.5. All right. All right, last part. The students are going to use the sample means. Okay, so these numbers here, the first three we calculated, to estimate the mean word length in the book. So select all of the true statements. Okay, so, oh yeah, and so it says, the students are going to use the sample means to estimate the mean word length in the book. So how many letters is the average word in this book? Is the average word 3.5 letters long, 2.9, 6.1? What is it? Okay, and they're trying to get an idea because it's a very important book to them. It's like Harry Potter or something. Like, man, we got to know every little detail, every subtlety about it. Okay, or like me with Star Wars. Okay, so here we go. Time to party. The closer the range of the sample means is to 0, the more confident they can be in their estimate. Versus the farther the range of the sample means is from 0, the more confident they can be in their estimate. Well, I think we can all agree you can't have both of them true. Maybe neither of them is true, but certainly not both. So they're talking about the range of the sample means. Well, this was the range right here of the sample means based on these 3 samples. Okay. Oh, something on my phone. And so, so what if that had been a 4.75 right there? Well, then our range of the sample means would have been the highest minus the lowest, which would have been 0. Oh, in other words, all 3 samples would have been the exact same thing. Okay. Suggesting, oh, okay, I feel very comfortable with assuming that that 4.75 words is is probably about right. Or I'm sorry, 4.75 letters in a word is about right. Okay, so we're going to do that first one. Okay, more confident, closer to range. Yeah, okay. Because on the second one, if the range of the sample means gets farther from 0, then that means maybe you've got like 8.75 and 1.25, and now the means of these samples are just all over the map, and therefore it's like, man, I don't know. I mean, what should we assume is the average length of a word? I mean, there's no consistency here. Okay. And so that's again why the second one is not going to be the answer. All right, the last two. Now these two again are diametrically opposed to each other. The mean of the sample means. Oh, we haven't done that yet. The mean of the sample means. So if you take the mean of these 3 numbers, because those are the sample means, you're going to get some answer, around 4.5-ish. Okay. So the mean of the sample means will tend to be better estimate than a single sample mean. Okay, so I just turned off the recording for a moment, and I don't even know where I left it exactly. I know I'm on the last 2 of these, but okay, so I might be a little repetitive. I'm going late. Cool. All right, so okay, so yeah, the mean of the sample means will tend to be a better estimate than a single sample mean. So yeah, what that means, I know I'm using the word mean a lot, but that's the word. what the mean of the sample means. Okay, what that signifies, what that means is you take all the sample means and you find the mean of them. So you say this plus this, and in this case, divided by 3. Okay, I think for many people, that's going to be kind of a natural thing to do. Okay, and just kind of take all the information, say, all right, let's just take all of that and get and combine all of it to get a better idea of what the what the average is going to be. All right. And it says that will tend to be a better estimate than a single sample mean. Yeah, a single sample mean. I mean, it could have been a good sample. It could have been a bad sample in terms of accurately reflecting what's going on in the book. Um, but if you combine several means, then you're much less likely, still possible, but much less likely to have an error or a really egregious error. So I'm going to go with yes. The last one, a single sample mean will tend to be a better estimate than the mean of the sample means. Well, that's kind of the exact opposite of what we read. Instead of, so that would be saying, yeah, I think I'll just take, I don't know, maybe that one, and I'll ignore these. And it's like, well, that was perfectly valid data right there. Why are you throwing that out? Let's keep all of it together, like we did on the third box. So that would be how you would do it.